So what do we know? The length, the width, and the height all together have to be up to 100 centimeters. The length is 10 centimeters greater than the depth. So if my length is 50, my depth would be 40. What does that leave me for my other dimension? Only 10. How did I figure those out? And how can I use that idea? How can I use that idea to do this with algebra? And this is a good strategy. When you're having trouble figuring out how to do the algebra, do it with numbers. So there's my suitcase again. Do it with numbers. What did I do? I picked something arbitrary for this. I called it x. Then I said its depth would be 10 less. That part would be x minus 10. Finally, how did I figure out what would be left? Well, I found out this last 10 by doing 100 minus both of those. If I would do 100 minus this one minus this one, that would leave me with, well, 110 minus 2x. This is a way to set it up. So I first looked at the numbers, and then after looking at the numbers, then I would go back and say, if I did the same thing with algebra, what would it look like? Now, how do we find our volume? Our volume is length times width times height, in no particular order. And this is where our knowledge of what we learned in the previous sections with polynomials comes into play. Can you see that if you multiplied this out, you would get a negative x cubed graph? So its end behavior acts like this. It's already in factored form. You could find the x-intercepts and graph it. Anyways, this is where we'll continue this afternoon.